We're going to do an example of solving exponential equations level 1, where we can rewrite the equation as a common base. And then I'm going to do this problem again where we use logs, even though logs is not necessary. So our equation is 128 times 2 to the power of x over 2 is 64. So what we can do is we can convert 128 and 64 in terms of base 2. So I'm going to do it on the side so you can see. So we know that 2 to the power of 1 is 2. 2 to the second power is 4. And we can always skip ahead as well. But 2 cubed is 8, because 4 times 2 is 8. 2 to the power of 4 is just 8 times 2, which is 16. Or we could have done 4 times 4, which is 16. So 2 to the power of 5 is 32. So we're almost there. 2 to the power of 6 is 64. And then 2 to the power of 7 is 128. So let's keep that in mind. 128 is like saying 2 to the power of 7. And 64 is like saying 2 to the power of 6. Let me just erase that. So let's rewrite this as 2 to the power of 7 times 2 to the power of x over 2 is equal to 2 to the power of 6. And recall that this is known as the product property. So with the product property, if two bases are the same, we can add up the powers. So therefore, let's change some color to alternate. We have 2 to the power of 7 times 2 to the power of x over 2, which is equivalent of saying, 2 to the power of 7 plus x over 2 is equal to 2 to the power of 6. And in mathematics, the equality property states that if two bases are the same, we can just ignore them and look at our powers. So therefore, x plus 7 over 2 is equal to 6. And to solve for x, we're going to solve it like a two-step equation. We need to get rid of the 7. So we need to subtract 7 from both sides. X over 2 is equal to 6 minus 7. So therefore, x over 2 is negative 1. And then we can multiply both sides by 2. Therefore, x is negative 2. So our answer is negative 2. So the way that delta map does it is they use logs. So in this example, log isn't necessary, but about half of the time you might have problems where you have to use logs. So this was not an example where you had to. So let's do an example where you might have to use logs. There's the screen. So in this problem, we have 10 to the power of x over 2 is equal to 80. So even though 80 is divisible by 10, you can't really write it as base 10. So therefore, we need to use logs here, right? A very common mistake is students would divide both sides by 10. So this is not allowed. And the reason why we cannot simply just divide both sides by 10 is because of order of operations. We're not multiplying x by 10. What we're doing first is we're taking x divided by 2 and then exponentiating with base 10, right? So very tricky. You can't just divide both sides by 10. So what we need to do first is see if you can, or we can rewrite it as base 10, and it doesn't work, once again, because 80 divided by 10 is 8, and there's an issue here. We can't write it as base 10. Because of that, we need to use logs. So 2 ways of doing it using logs. We can either take the log base 10 of both sides, or we can rewrite it as a log. So if you prefer to take the log of both sides, I highly recommend doing that. And when you write log base 10, that's the same thing as saying log without the 10 by default. So we need to take the log of 10 to the power of x over 2 is equal to log base 10 of 80. These two will cancel out because they're inverses. We learned about that before the break. That log base b of b to some power are inverses, so they cancel out. Because remember, there's an invisible 10 here, right? There's an invisible 10 here. But we don't normally write that, so let me just erase this. I'm trying to double tap. So we have x over 2 is equal to log of 80. So we're almost there. All we need to do is get rid of the 2. So the inverse of dividing by 2 is to multiply by 2. So we can just multiply both sides by 2. Therefore, these two cancel out. And next is 2 log of 80. So we need to type it into a calculator. I'm gonna use desmos.com. Type in 2, go to functions, go to the one that's just a single log, because we don't need the base. 80, close the parentheses, press enter. We get x is approximately 3.8. However, the 0, the number to the right of 0 is a 6. And because 6 is greater than or equal to 5, we need to round up. So it would be 3.81 approximately. 3.81. Press enter, press yes. Dollars. All right, so first off, let's copy down the compound interest formula, which states that A is equal to P times 1 plus R divided by N raised to the power of NT. So A is the final amount. P is the principal amount, aka your initial amount. R is the rate. N is the number of times you compound within a year. And T is always the number of years. Okay. So we need to dissect this. A person invests 4,500. So we know that the principal amount is 4,500. The final amount is 5,900. That's what we want. So N is the number of times you compound something. So if it's semi-annually, then it's twice a year. Suppose it was monthly, then N would be 12. If it was weekly, N would be 52 because there are 52 weeks in a year. And if something is being compounded daily, then N would be 365 because there are 365 days in a year. So N is 2. Now R is kind of tricky. The rate is 4.75%. However, to convert 4.75% into a decimal, we need to move the decimal point 2 spaces or 2 placeholders to the left. So it will be 0.075. So the rate will be 0.0475. And T, well, T is what we're trying to find. So let's write down the formula. It'll be 5,900 is equivalent to 4,500 parentheses 1 plus, because we're gaining money, that's why we're adding, plus 0.0475 divided by 2 raised to the power of 2t. Now, if you have a graphing calculator, you can store this particular number. So there's two approaches to it. You can either store it into your calculator, or you can keep it whole. Sorry, something's wrong with my iPad. 0.475 divided by 2. It'll be 1.02375. If your number has a repeating decimal, I would highly suggest that you keep it as a fraction. But this problem is not too bad. We're going to copy that down as 1.02375 raised to the power of 2t. So let's think about our order of operations here. With the t, we're multiplying by 2. We're exponentiating with the base of 1.02375. And then we're multiplying by 4,500. So to solve for t, we need to reverse the order of operations. We need to divide both sides by 4,500. All right, so the zeros are going to cancel out, and we'll keep it as 59 over 45 is equal to 1.02375 raised to the power of 2t. So we don't really need the parentheses now that we've gotten rid of the 4,500. So we have this. So now what we need to do is we need to rewrite this log as, so you can rewrite it as an exponent. So it's in exponential form, so you need to rewrite it in log form. Or what you could also possibly do is to take the log of both sides. So depending on how you want to do it, but we can rewrite it as a log. So we rewrite as a log, it'll be log base 1.02375 of 59 over 45 is equal to 2t. So we're almost there. Now we need to get rid of the 2. So we need to divide both sides by 2. You can also multiply both sides by 1/2. Because 2 times 1/2 cancels out. So our answer is 1/2 log base 1.02375 of 59 over 45. So we are going to use Desmos to type this. Desmos can use base whatever. So what we can do is we don't need to use the change of base formula. We can type in 1/2, move it over. You need to go to functions, go to log base A, type in your base, which is 1.02375. Over and do 59 divided by 45. So it looks like the answer is 5.77. However, they wanted us to write the answer to the nearest tenth. So 5.77 is 5.8 years. And the reason why we round up is because 7 is larger than 5. So therefore we round it up. And if you look at the problem, the way that Delta Math does it is they use the change of base formula. So that's why you see this here. You don't need to use the change of base formula if you have a calculator that can do log base b. If we were to use the change of base formula, then what we need to do is to calculate this section, we need to do log of 59 divided by 45 divided by log of the base, which was 1.02375. So let's show you what that looks like. So you would have to do, I'll use 0.5 instead of 1/2. You need to do 1/2 times log of 59 over 45. Make sure that you go over and then close it. Divided by log of 1.02375. Close it, and as you can see, you get the same answer. Right?